Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am your chemistry teacher here. We are going to start revision for final term. Today we discuss about the shell and the subshells, which is mentioned in chapter number 2, atomic structure, on page 49 and 50. And also these topics are present in your notes from question 8 and 9. So we discuss about the shells and the subshells. Shells are further classified into the K, L, M, and N, and the subshells are further classified into the S, P, D, and F. So, we discuss the shells and the subshells one by one. First of all, we discuss about the shell. Shell or orbit. We can also say that the shell, orbit, or the energy level. So, according to the Bohr atomic theory, electrons are revolving around a nucleus in one of the fixed circular path called a shell or the orbit. According to the Bohr theory, that electrons are revolving in a fixed circular path, and this fixed circular path is known as a shell or orbits. Each shell has a fixed energy. These orbits or shells are also called the energy levels. You can see on your screen that the Bohr model of the atom. In the center, nucleus is present, and nucleus consists of the protons and the neutrons and electrons revolving around a fixed circular path, and this fixed circular path is known as orbit or the energy levels. Then main points about the shell, orbit, or the energy level. Each shell is described by the n value. N means that the n value shows the number of shells. N can have the values like 1, 2, 3, 4, and so on. As the value of n increases, shell number also increases. If the value of n increases, like n is equal to 1, 2, 3, so the number of shells increases, and the distance of electron from the nucleus increases. When the shell number increases, so the distance of the electron from the nucleus also increases, and the third point, that the energy of the electron also increases. Three points are interconnected. If the number of shells increases, so the distance of electron from the nucleus increases, and also the energy of the electron also increases. As you can see on your screen, that's the atomic structure. In the center, protons and neutrons is present, and electrons revolving in a fixed circular path called orbit, energy, or the energy levels. If we have the n is equal to 1, so here the distance of the electron from the nucleus is low, and that's why its energy is low, as compared to the n is equal to 2. N is equal to 2 means that they have the energy is higher than the n1, means that they have the higher distance as compared to the n1. As you can see that the increasing distance from the nucleus, so increasing the energy. When increasing distance from the nucleus, so its energy is increased. When n is equal to 1, having low distance, so its energy is minus 13.6, and you can see that n is equal to 3, the distance of the electron from the nucleus increases, so its energy is also increases, minus 1.51 electron volt. Then shell names. Shells are represented by the alphabets K, L, M, and so on. These shells or orbits are represented by the alphabets like the K, L, M, and N. And these shells also are numbered as n 1, 2, and 3. 4 means n is equal to 1, n is equal to 2, n is equal to 3, and so on. The electrons present in the K shell, n is equal to 1, have the least energy and is nearest to the nucleus. The electrons which is present in the K shell have the least energy, have the low energy. Why? Because it's nearest to the nucleus, because the distance of the electron from the nucleus is low. Then the L shell, n is equal to 2, is the next shell which is the higher in energy than the K shell. So you can see on your screen that the Bohr model of an atom, these shells are represented by K, L, M, N, and N, numbered as 1, 2, and 3, and 4. So the K shell have the least energy as compared to the L shell. L shell have the high energy as compared to the K shell. Now we discuss about the subshell. What are the subshells or the suborbit? A shell or the energy level is divided into the subshell or the sub-energy levels. When we divide the shell or the subshell, like we have the main heading like the shell and the subheadings like the subshell. So, there are four subshells. The subshells are represented by S, P, D, and F. We have four subshells. These subshells are represented by S, P, D, and F. The spectroscopic terms, so subshells are the spectroscopic terms which stands for S stands for sharp, P stands for the principal, D stands for diffused, and F stands for the fundamental. Now we have the subshells are denoted by S, P, D, and F. S stands for sharp, P stands for principal, D stands for diffused, F stands for fundamental. And here also their structures are present. S have the spherical shape, P having the dumbbell shape, D having the double dumbbell shape, and F having the complex shape. Then you can see on your screen that these are the shapes. S orbital are the spherical, means that in the form of a circle. Then P orbital means dumbbell shape. Dumbbell shape means having two loops. And in the D orbital having the double dumbbell shape. Double dumbbell shape means having four loops, and the D orbital having the complex shape, and these complex shapes will be discussed in the higher grades. Now we discuss these types of the subshells one by one. There are four subshells: orbit sub, S subshell, P subshell, D subshell, and the F subshell. So first of all we discuss about the S subshell. S stands for the sharp. It is spherical in shape. S shell has one orbital just. S subshell have one orbital just, and it can accommodate maximum 2 electrons. So S stands for the sharp. It is a spherical in shape. It has only one orbital, and one orbital can accommodate only 2 electrons. One orbital can accommodate 2 electrons, so it can accommodate only 2 electrons. Like you can see, it's a spherical shape, and these spherical shape are oriented or rotated like in the x-axis, y-axis, and the z-axis. Now you can see your screen this video that this is the s orbital, and they move on the x-axis, y-axis, and the z-axis. Then P subshell. P stands for the principal. It is the dumbbell in shape. It has the three orbitals like the px, py, and the pz. It can accommodate maximum 6 electrons. P stands for the principal. Dumbbell in shape. Dumbbell in shape means that they have the two loops, and it has the three orbitals. We can discuss that the one orbital can accommodate only 2 electrons, and here 3 orbitals are present, so 3 multiplied by 2 is equal to 6, so it can accommodate maximum 6 electrons. Then it's the p orbital, and these p orbital are oriented along the x-axis, y-axis, and the z-axis. It is a dumbbell in shape having the two loops. Then px oriented, py oriented, and pz rotations, or also we can say that these are oriented or rotation along the p-axis, along the py, and along the pz. You can see on your screen that it's the orientation or the rotation of the px orbitals. These px orbitals are rotated in a between the shells. Now the py, these are the py orientations, and then we discuss the pz orientations. These are the pz orientations along the z-axis. Then we discuss the D subshell. D stands for the diffuse. It is a double dumbbell in shape, means having the 4 loops, and it have the 5 orbitals like the dxy, dyz, dzx, dx square, or dx square, y square, dz square. It can accommodate maximum 10 electrons. So D stands for the diffuse. It is a double dumbbell in shape. It have a 5 orbitals, and you know that the one orbital can accommodate 2 electrons. So 5 multiplied by 2 is equal to 10. So it can accommodate maximum 10 electrons. Now These are the orientations or the rotation of the 5d orbitals. These are the 5d orbitals. The first one are the dyz, the xy, the zx, the x square, y square, the z square. Then you can see on your screen that's the orientation or the rotation of the d orbitals along the x and the y, then along the x and the z, then the x square and the y square. Then we have the dyz, orientation of the d orbital along the y and the z. Then we can proceed at the F subshell. For F stands for fundamental. It has a complicated shape. It has the 7 orbitals. It can accommodate maximum 14 electrons. It have the 7 orbitals. So 7 multiplied by 2 is equal to 14. So it can accommodate maximum 14 electrons. Its complex shape, and this complex or complicated shape will be discussed in the higher grades. Now you can see that S, P, D and F, these blocks shows the orbitals. These blocks shows the orbitals. Or what are the orbitals? Having the three-dimensional shape where the probability of finding of the electron is almost or the maximum. So in the s orbital, in the s subshell, we have just one orbital, and this one orbital can accommodate two electrons. In the p orbital, we have the three orbitals px, py and pz, and it can accommodate 6 electrons. D have the 10 orbitals. If you can count 1 2 3 4 and 5, 2 multiplied by 10 is equal 2 multiplied by 5 is equal to 10 electrons. And in the last shell you can count 1 2 3 4 5 6 7. So 7 multiplied by 2 is equal to 14 electrons. Now shell number, we have like the shell k shell have the 2 electrons. K shell can accommodate 2 electrons. Mm, L shell can accommodate 8 electrons. M shell can accommodate 18 electrons. So these electrons are found by the formula like the 2 and square. We have the shell number 1 2 3 4 5 6 and 7, and also we can, these are the, they are numbered as, and we can, if we can, like the alphabets K L M N N. So the formula like the 2 and square, 2 multiplied by 1 is equal to 2, 1 multiplied by 2, then is first shell can accommodate 2 electrons, second shell can accommodate 2 electrons. If we put n, and instead of the n we put 2, so 2 multiplied by 2 is equal to 4, 4 multiplied by 2 is equal to 8, and then so on. Now we have the shell and the subshell. So shell and the subshell, like the n is equal to 1 2 3 and 4 k l m n n, and in the center nucleus is present. And also we have the subshell. K shell can have the subshell S, L shell can have the subshell SP, and M shells can have the subshells like S, P, D and F, and N shell have the subshells like the S, P, D and F. So N is equal to 1 K shell, N is equal to 2 L shell, N is equal to 3 M shell, N is equal to 4 N shell, and the subshells can accommodate like the 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D and 4F.